Hey guys, so let's get started on the review of this past week's four ACT questions of the day. So this entire week was geared towards ACT science, and you can see on the screen here that this set of questions was just jam packed with information. There's a passage here that takes up the entire left column of the page. It has a diagram, there's some chemical equations. Then you have two different experiments, and they both have figures and charts and keys and all of that. And as you can see, like I have to scroll down even for you to see the entire information here. Let me just zoom out if I can. Actually, I can't even zoom out. So hopefully you can see that this just had an overwhelming amount of information attached to this set of four questions. So let's look at the questions here. And before I get into it, the reason why I wanted to go on and on about how overwhelming that information is because I want to drive home the point again that we're not going to get distracted by the long passages and the charts and the information. You're not going to go right in and read that passage. You're going to go directly to the first question, read it, and see, S-E-E, see where the question is directing you. So we're bypassing the passages, bypassing the charts and figures and all of that, and we're going to the questions and seeing where are the questions directed. Okay, so here's our first question here. It says, consider the volume of gas collected in the trial in experiment 2. That should be like ringing bells for you in your head that when I go back and look at that other column or that other page, I want to direct my attention to experiment 2. And then I'm going to be looking at the element Ni, and at this moment that leaves me. So I don't want to quote that element wrong. But Ni, whatever that is, that's what we're looking for experiment 2 at 30 degrees Celsius. So they're very specific with the directions of where you need to go. We're looking for experiment 2, Ni at 30 degrees Celsius for the volume. It says consider the volume. Okay, so we need to know what is the volume during experiment 2 for Ni at 30 degrees Celsius. Then the same approximate volume of gas, whatever that was collected in the trial in experiment 1 for what mass of Ni. So we need to go find the volume, then use that same volume in the other experiment and determine the mass. It told us exactly what to do. It gives you a roadmap. So when you go back over to the information, you're going to follow along, follow the roadmap that they gave you. Marker here. So the first thing they directed us to was experiment 2. Down here, experiment 2. And then they said Ni. And I know Ni is right here according to the key. This is the one that has the open square on it. And then they want me to do 30 degrees Celsius. So temperature is on this axis, got 30 degrees Celsius right here. And I'm going up to the one that's open square. Okay, you zoom in a little bit, you can see that there. Okay, so when I zoom in, it changes where all of my markings were. Sorry about that. Like a blooper kind of day. And I know when I go up to experiment 1, I'm going to have to clear it out again. So anyway, just want to make sure we're looking at Ni, and I want you to be able to see it. Open square, 30 degrees Celsius, right? Going up to the open square, which is like a little less than 130 milliliters of volume of gas, right? So it's not quite 130, but it's somewhere in there. 127, 128. So keep that in mind. We want that same volume when we go up to experiment 1, still looking at the element of Ni, and we want to see what the mass is when the volume is 127-ish. Okay, so let's go up, be clear. We're going to go up. Experiment 1, come on. Okay. And again, Ni is the open square. And the volume needs to be like a little bit shy of 130, going until we get to the open square, which is here. And what's the mass? That mass is 0.3 grams. So that's going to be our answer to this first question, 0.3 grams, which should be answer choice H. Okay, but notice here, nowhere at any time did I read the passage. I didn't even look at the diagram. I have no idea what this experiment is even about. And it doesn't matter. I just need to get the correct answer as quickly as I can. And so we're going to the question and let it direct us. Okay, so the answer to the first question is H, 0.3 grams. All right, let's take a look at the second one. It says, how many temperatures were tested in experiment 1? Temperatures, experiment 1. So it directed you to experiment 1 specifically for temperatures. And how many temperatures were tested in experiment 2? So that means I'm just going to be looking at the experiments, and I'm just going to be looking at the temperatures and counting how many they are. I'm not going to get distracted or bogged down by any of the information. Let's go back. Experiment 1. Doing a quick scan, I see mass, I see volume. I don't see anything about temperature in this chart. Let me look up in experiment 1. In each trial, a selected mass of Fe, which I think is iron, but like I said, I'm not going to quote these elements because I don't remember. Fe, Ni, Zn was tested at 30 degrees Celsius. There's your temperature. There's only one listed, no other temperatures in the figure. So experiment 1 has 1 temperature. Okay, then we want to go down, except for my mouse doesn't want to work. Don't know why that is, but let's look at experiment 2. And we can see volume and then temperatures, right, across the bottom. And we have temperature 1. Then, and I know this is, they're using temperature because they're marked right here. So I know it's at 10 degrees, that's 1, 20 degrees, that's 2, 30 degrees, 3, 40 degrees, 4, 50 degrees, 5. So there were 5 temperatures tested in experiment 2. Okay. So we just need to go back to our answer choices and say which one has a 1 for experiment 1 and a 5 for experiment 2, and that's B. Right? And again, I've answered a question without looking at the passage and unnecessary information. Okay. Hopefully, if you've been following this series of Freeview Friday or Monday where we got off track, if you have been following this series of solutions to those questions, especially the science section, then hopefully you're picking up on the pattern that we're going directly to the questions and not, wasting time with reading the passages. Okay, let's move on to question 3. Which of the following statements describes a difference between experiments 1 and 2? So what's the difference between experiments 1 and 2? Again, they're directing us to those figures and the information about the experiments. And then it starts off, don't miss this, in experiment 1. So you need to say that before you read every answer choices. You need to say that before you read every answer choice. Okay. And I would go through each of these and determine if they are true or not. If not, then I'm going to eliminate it And what will happen here is we will eliminate all the incorrect answers and we'll be left with the one right solution. So in experiment 1, only FE was tested, but in experiment 2, FENINZN were tested. Let's check. Let's look back at experiment 1. Quickly looking at the key, I see 1, 2, 3 different elements. So that means more than just FE was tested in experiment 1. So that is incorrect. F, that answer choice, is not right. FE was not the only thing tested in experiment 1. Moving on, answer choice G. Remember to say your phrase. In experiment 1, FE, NI, and ZN were tested, but in experiment 2, only FE was tested. We can look back, we can see, okay, yeah, all 3 were tested in experiment 1. Go down to experiment 2, and I can say, 1, 2, 3 were tested in experiment 2 also. So G is incorrect as well. Scratch it off. Moving on to answer choice H. This one says the same mass value of each metal was tested. Oh, I'm sorry. I should read the phrase like I was telling you guys. In experiment 1, the same mass value of each metal was tested. But in experiment 2, multiple mass values of each metal were tested. Let's go back. In experiment 1, they said only one mass value. I'm in experiment 1. I'm looking down at the figure. I see mass across this horizontal axis, and it has been tested 1, 2, 3, 4, 5 times in experiment 1. So therefore, it is incorrect because they said it was only tested 1 time in experiment 1. Okay. So that means we have eliminated F, G, H, and therefore J is the only one left and has to be the correct answer, but you could look at it and confirm it to make sure. So J says in experiment 1, multiple mass values of each metal were tested. Yes, we just saw that was the case. But in experiment 2, the same mass value of each metal was tested. So you can check, yes, experiment 2. In each trial, all of them, all 5 trials, 0.3 grams. So they have the same. Okay, so that's the correct answer. All right. So guys, I want to encourage you to make sure you join the group ACE the ACT exam on Facebook if you haven't already done so. Every day, Monday, Tuesday, Wednesday, Thursday, an ACT question is released. Generally, they're math and science. We will be incorporating English and reading very soon. But those questions are posted weekly, and on Friday, we go through and give the detailed, easy to follow, step-by-step solutions along with strategies and tips to get you to that correct answer. So make sure you join us here every Friday for those review questions. So guys, we're going to go right on in to the last question from this week. It says, which of the following variables remained constant throughout both experiments? So experiment 1 and 2, that's where we're going to go and look. Which of the following variables remain constant? And so what I can do is check these answer choices and see if they remained constant. If so, that's going to be my answer. If it didn't, then I can eliminate it. Okay? So that's what I'll do. Let's look and see. Atmospheric pressure is the first thing. I can go up here. I actually don't see anything about pressure at all in the figure. Like mass is here, volume is there, temperature. I don't see anything about pressure. And if I go down to experiment 2, I see temperature, I see volume, I see mass. Don't see that. So I'm going to move on. I'm not going to make a decision about that. Let's move on to answer choice B. Did mass remain constant throughout both experiments? Mass. Right. So in experiment 2, mass is constant, but in experiment 1, mass is not. and it said it had to remain constant across both of them. So I can eliminate answer choice B. Mass was not constant across both experiments because it changed in one of them. Answer choice C is temperature. Let's go back and check it. In experiment 2, temperature is changing, right? 5 different times. So that's not constant. I can go ahead and rule it out. I don't even have to check experiment 1 because it had to be constant for both of them. So let's get rid of C. So now we're just down to A and D. Okay, let's check D. Did the volume of the gas collected change? Or I'm sorry, did the volume of the gas collected remain constant? So in experiment 2, the volume, oh wow, right in the middle of a video. Okay, thanks Facebook for flicking out on me right in the middle of doing this live training. Anywho, we're checking to see if the volume, if the volume of the gas collected remained constant. So when we look down in experiment 2, we can see that the volume is changing. So that's not remaining constant. I don't have to check experiment 1 because once again, it said constant across both experiments. And since it didn't work for one of them, it gets kicked out. So we've eliminated B, C, and D. Therefore, the answer is A. And I don't really even have to know if somewhere over here on the left column in all of this information that they mentioned atmospheric pressure. That doesn't matter. I have determined that that is the correct answer because all the other ones were incorrect. Okay. So guys, I really hope that this training has been helpful for you, this review of the ACT questions from this week. Remember, come back next week for more questions. And if you'd like more help, more support on ACT tips and strategies to help you raise your score so that you can be admitted into the college of your dreams and or to qualify for tons of scholarships and avoid student loan debt, then I encourage you to book in for a strategy call. It's absolutely free. There's nothing to buy on the call, even if you wanted to. It's just to see how we can help you raise your ACT scores. I do have 5 slots coming up next week. So if you'd like one of those slots, then please use the link below to book in a time to speak with us so we can help you raise your ACT score. All right, guys, have a great weekend. See you next time.